Hey, welcome back to another online lesson. We are talking lesson 1.1. We're going to talk factors and multiples today. Greatest common factor. You know, it's probably a skill you've done in years past. This is something in 6th grade we like to build upon. Greatest common factor. The greatest common factor, or GCF, is the greatest of the common factors of two or more numbers. Your takeaway from this, in class, we're going to constantly refer to GCF. Know that to be greatest common factor. Okay. A skill you may or may not be familiar with is factor trees. And we're going to do a factor tree here. So the question states, find the prime factors of 30. All right. In order to do that, you make a factor tree. To do that, you start with your number, which is 30. Perfect. All right. Now what I do is I offshoot 2. And think to yourself, are there 2 numbers that you can multiply to get 30? Sure, there's a couple different answers, but the one that popped in my brain was 15 times 2. Right? 2 times 15 equals 30. Awesome. But like a tree, it has many different branches. So let's go down that 15 branch and say to yourself, are there 2 numbers that you can multiply to get 15? Well, ideally, you're probably thinking of 5 and 3. Perfect. Now, one thing I failed to mention was in factor trees, some of you may have thought like, oh, 15 times 1. Well, it's all non-1 numbers, right? And I'm going to show you what I mean by that right now. So say we have 30 goes to 15 times 2, so 15 we now shoot down to 5 times 3. Now, look at 5. Are there 2 numbers that you can multiply to get 5? Well, we have 5 times 1, and there's really no other whole number you can multiply to get 5. So therefore, that is prime factor. We're going to circle 5. And the reason we're circle 5 is that there's no number that you can multiply to get 5. What about this 3? Ask yourself, are there numbers we can multiply to get 3? No, only 3 and 1. So that is prime factor. So now we're done with that branch because, well, we came to 2 stops. So now let's move to this 2. Are there numbers you can multiply to get 2? Only 2 and 1. So that branch stops. And when all of your branches stop, therefore you have found the prime factors are 30. The prime factors for 30 are 5, 3, and 2. Hopefully you've seen factor trees before, but if you haven't, don't worry. We're going to work more on it in class, and in fact, we're going to work on this next problem because you use factor trees to find the GCF. So here is a typical GCF question, of greatest common factor. Factor trees to find the GCF. Find the GCF of 12 and 18. Okay, I gave you the steps right here. First, do a factor tree for each of the numbers. So I'm going to take 12 and 18. Okay, 12. Again, with a factor tree, you're just thinking, are there 2 numbers that I can multiply to get that number? 12, hopefully you thought 6 and 2. Now, if you did say 4 and 3, that would be okay. You're going to get the same result. So now I go to my 6. Are there 2 numbers that I can multiply to get 6? There are, 3 and 2. Perfect. Now I go to my 3. Are there 2 numbers that I can multiply to get 3? No, it's only 3 and 1, so that stops. What about 2? Again, just 2 and 1, so that stops. So that whole branch is now stopped. Let's go over to this side. That is 2. Whoa. Are there two numbers that I can multiply to get 2? I don't think so, so that branch is stopped. Perfect. So now we have 12 as 3, 2, 2. Awesome. Let's move to 18. Over at 18, two numbers I can multiply to get 18. I thought 6 and 3. 6 and 3. Perfect. So now let's move to my 6. Are there two numbers that I can multiply to get 6? There are. 3 and 2. Coming down from that 3, we know we can't go further on 3. It's got to stop. Coming off of 6, 2, it has to stop there. And at 18, 3, it's got to stop. So therefore at 12, my prime factors are 3, 2, and 2. And for 18, my prime factors are 3, 2, and 3. Okay. Step 1, done. Now let's move to step 2. Step 2. Next, find the factors that they have in common. Basically look at it as it's like they got to have a date. So I have a 3 over here with the 12. Does that 3 have a date over at 18? Ding, ding, ding. Yes, it does. So therefore, we have 3 in common. Now I have a 2. Does that 2 have a date over here? Ding, ding, ding. Yes, it does. 2. Now I move over here. I have a 2 with the 12. Do I have a 2 over here? No, I do not. Sorry, 2. Not invited without a date. Let's move to 18, see if we have all those numbers. 3, you're gone. 2, you're gone. What about that 3? There's no date on the other side, so 3, you got to go too. Boom. So therefore, I have 3 and 2. The last one says last, multiply the common factors together. So we're going to take 3 and 2, we're going to multiply them. 3 times 2, that equals 6. Therefore, find the GCF of 12 and 18. The GCF is equal to 6. Awesome. So that's just one part of the lesson. Let's move on to least common multiple. Okay. Find the least common multiple, or LCM, of 2 and 3. Okay. Well, in order to do this, what I do is I set up a little chart. Multiples will get bigger. So we're going to do 2 and 3. And usually I start with 1, 2, 3, 4, 5. Cool. Multiples. What we're going to do is we're going to multiply these numbers times the top. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Perfect. Now, to find the least common multiples, what you have to do is you have to look and say, okay, now I have my chart done. Where is the first time that they match? Well, I see a 2 and a 3. That doesn't match. 4, no 4. Ooh, but I have a 6. Notice how there's a 6 and a 6 here? Therefore, my LCM is going to be equal to 6. Let's try another one. This time we're going to find the least common multiple of 4, 5, and 10. So what I do to set up my chart is I take my numbers 4, 5, and 10. And I put like a gigantic division sign over it. I usually begin by going 1, 2, 3, 4, 5. And we'll see in class that oftentimes you're going to have to go further than 5. But I always start at 5 because hopefully we can find the answer within the first 5. So let's multiply across. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And 4 times 5 is 20. Let's go to the 5s. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. Huh? Huh? 5 times 5 is 25. Cool. And this one. 10 times 1 is 10. 10 times 2 is 20. Ooh. Now hopefully, as you wrote, you kind of picked up and you realized that 20 appears here. 20 appears here, and now 20 appears here. That, ladies and gentlemen, is your LCM. LCM equals 20. Awesome. Now, these you may be familiar with, you may not be familiar with. Don't worry though. In class tomorrow, we're going to work on these. You'll have them down pat. And even have a little song to sing about these. Until next time, see ya.